So it's the first radius. So that if this atom here has got more than one shell, R1 will be what is depicted on the screen, right?
Yes.
Now, this, therefore, can be what?
R2.
R2. So let's write R1 in small letters. And so this is R1 in small letters. So now here we have R2. So on and so forth. Where about you can have Rn. So we say this is Rn to the n. So this will be Rn. And that is if this is a dotted radius to show that it's indefinite. So this is important. Now, this formula, this is what you need. This is all you need for the radius. Now, what about the velocity? The velocity follows a similar. So the velocity of the electron in any shell number n. So n is shell number. And of course, n will be what type of numbers?
Real numbers?
Excellent. Real, but integers, right?
Yeah.
1, 2, 3, dot, dot, dot to the infinite, right? Shouldn't be very difficult for us to figure it out. We just have to, put on our thinking caps. So how do we do that? We say, look, we speak the English of the question, solution. So we say, look, in the Bohr model for hydrogen, an electron in the ground state has an orbit radius O. So there's an electron with an orbit radius. So we data. It's got a radius, which is R for us. What is the orbit radius? R. So we say radius. And they tell us in the ground state. So this radius, what surname does it have?
Initial radius?
Excellent. So it's R1. The value of R1 is R. Good. Now, and they say it has got speed V. Of course, this speed V is also the one pertaining to which state?
To the initial one.
To the ground state. Therefore, we're talking about V1, V sub 1. So the value of V sub 1 is V. You look at your equation, you have Vn will be depending on V sub 1 over n, right?
Yeah.
And interestingly, V1 should be equal to the first V1, which is V, over 1, right?
Yes.
So it applies.
No, I did that.
So that gives you V. It just confirms the data. Can we do that for the radius? How about the radius? So because now they say, look, there is in the first excited state of the electron. So that state now, what number will you attribute to the first excited state of the electron?
Oh, R2 is equal to 4R?
Good. Of course, this 4R is because of what you said. What did you say? Is due to?
Orbit.
Yeah.
The radius?
So
orbital.
So listen, what I understand, you say the question tells you that R2 is 4R, but of course you could also confirm that, okay, 4R should be equal to, in this case, N squared over R1, which would mean, in this case for R2, it will be 2 squared times what? R1. What is R1?
R1 is R.
So 2 squared is what?
4.
Excellent. So indeed.
Oh, that's correct.
So you tick, it confirms, right?
Yes, sir.
You follow?
Yes, yes.
But do they want the radius? Is the question interested in the radius per se?
No, they want the speed.
So they want the
velocity.
speed. So what is the speed? So they say, what is the speed in the first excited state? Indeed, what speed are they talking about?
They're talking the ground speed.
First excited state. What speed is that?
Wait. V 2 over n?
Let's reason, Hosanna. The ground state is when the electron is in the first shell.
Yeah, no, the ground state is when it's oh no, so is it V1 over n?
The ground state it's when it's in the first shell. You have to understand that.
Okay, so
Very
that's
close to the nucleus. You can even think of the ground state as the electron basically just, of course we know it's moving, but it's where
yeah.
it's at home, I mean, basically. But
Okay,
now when we
okay.
talk about excited state, what has happened for it to be excited? Can you narrate that?
Energy.
The photoelectric effect, which is sort of a microcosm of giving it heat, but in this case, it's not heat, it's light. Okay?
Yeah.
Yeah.
Okay,
So,
I get it.
yeah. Here, you just have to know that the electron can jump from one shell to the other due to external factors that affect it, right?
Yes.
Now, ground state just means n sub 1, okay?
Okay, so V sub 1.
Oh, v sub 1.
Oh, I get it. I get it. I get it. I get it. I get it.